Hello everyone, I'm MLinguist, and I will be starting the live stream as soon as I verify that my audio is heard on the other side. Okay, I think we're good. So, I have to do a little bit of explaining before we start, because today, if you tuned into the stream yesterday, you'll remember that I said that I was going to do 20-point problems here on this stream, but I was going through the more recent problems from 2021, 2022, 2023, and there's not as many 20 and 25-point problems. They're more split up into 5, 10, and 15-point problems. So I decided instead that on this stream we were going to work on the 15-point problems. And the first problem we're going to work on is from 2022. It's called Stopping for a Spell, and it's 5 points. But it's a two-part problem. So the next 15-point problem continues off of this work. So let's choose a nice color. I think I'm going to go blue today. Yeah. Also going to make the line a little thicker so that it's more visible on screen. I think that's good enough. Yeah. Let me know if you can't see it well, but I'll zoom in a little bit too. Okay. Many types of technology have to convert writing to sounds, a process known as text-to-speech. For example, a GPS needs to read street names to the person driving the car, and virtual assistants such as Siri or Alexa may need to read text from a web page. An important step in this process is grapheme to phoneme conversion. Changing a sequence of graphemes, the basic units of writing such as letters, to a sequence of phonemes, the basic units of speech. In this problem, we'll study finite transducers, one type of system that can perform grapheme to phoneme conversion. Below is an example of an FST. The FST takes in a sequence of letters in lowercase before the colons and outputs a sequence of sounds in uppercase after the colons. The FST starts at the circle labeled start. When it reads in some lowercase letters, it follows the arrow marked with the letters, so here or here, and also outputs the phonemes associated with the letters until the entire input has been used up. For example, given the input siding, the system would produce sading. Siding, okay. This is a special symbol which means that no output is produced. For the input side, the output is side. Yeah. We need to represent the letters and sounds differently from each other because letters can be pronounced differently in different words. For example, the letters ED can pronounce duh, as in timed, or ud, as in sided. Okay. Oh, okay. So the reason why we have this split is because the vowel sounds following these words change in English. So, yeah. That's interesting. Okay. What output would the system produce for the following words? Time. I think we just follow this, right? T T, I, M, E, time. Oh, that's interesting, because this is a silent E at the end of the word. Okay, let's put that in. Since this is a 5-point problem, you'll notice that it's a little easier, but the 15-point problem that follows this is going to be much more difficult. Okay, traded. Yeah, let's just start writing it. T-R-E for A, E-Y, trade, U-H-D. Traded. The nice part about this problem is that you can test it by reading it. So if you got it wrong, you'll probably know. Striding. Striding. Framing. Okay, so we're done with L1. Sometimes when the system reads in a letter, there are two possible paths it could follow. In such cases, it tries one path, and then if it gets stuck, it backtracks and tries a different path until it finds one that works. Somewhat like how you might solve a maze. Exactly one of the following three words could potentially force the system to backtrack. Which one is it? Well, I don't think it's fading, because fading would start at the start. A, F-A, right? F-A, then it would go to D, D, then it would go to, oops, what? Okay, then it would go to I-N-G, and then it would be done. Like fading, yeah. So that would not backtrack. So we can cross that out. So fading would not backtrack. Stage. So it would start here. S-T-A-G. No, it would go S-T-A-D-G-E. But would it backtrack for this one? Maybe. So let's put a little maybe symbol by it. Okay, name. N-A-N-A. That's not gonna, that looks like Nemo, but that's not going to affect. Also, I just realized that I'm putting the cross the wrong way for the O, or not the O, the silent E marker. So let's just do that again. Okay, name, no, so it has to be stage. Okay. L3. A path is only valid if it ends at a position with a double circle. With this fact in mind, what output would the system on the previous page produce for the following inputs? Okay, staging. I wonder what time it is right now. Let me see. Okay, it's 4:47 because I wanted to put like this word staging in this like form into a text to speech to see if it would work. Let's just do that to see what it would sound like. I hope I am sharing desktop audio. Let's start text player and synthesizer. Okay, we're going to type in staging. Staging. Okay, I'm going to drag the tab up. So we've got staging, you can see. Oops. Okay.
Ing.
Oh, it didn't seem to work. I think that if you type in staging, it'll probably work, but it didn't seem to work with this, like, different spelling. Let's go here, fill that in. Stay DJ IHNG gaming. Okay. GEYMING. Gaming. Yep. Okay. Many English words are spelled very strangely. For example, kernel is pronounced kernel, like kernel. There is an R in the pronunciation, even though there is no R in the spelling. The FST below is designed to handle some of these exceptions. Match the arrows 1 through 6 with their labels A through F so that the system gives correct outputs for the 5 words listed under the FST. Right. So the start has to be C because it's supposed to start with all of these start with consonants like he, people. Yeah, there we go. People. So I think E comes after because the P sound is here. Because it was people. And then O is at the end right here. Kernel. could put B for 3, and then F for 6. It works for kernel. And then for, so we only have, wait, let's cross off the ones we've done. B, C, E, F, S, E, phase, right, phase. A, yeah, so A has to go here, then it's D. Okay. So far, smooth sailing, but it's gonna get harder. Okay. When using an FST, it's possible to swap what counts as the input versus the output. In our case, this means that we can provide a sequence of sounds, the symbols to the right of the colons, and have the system produce letters, the symbols to the left of the colons. Since this system is converting sounds into spelling, this process is something like having the system compete in a spelling bee. When you're using the previous FST, the one that handles kernel, you try asking it what sequence of letters would be pronounced roughly. Yeah, you expect its answer to be roughly, but instead you get something very different. What sequence of letters does the system say would be pronounced roughly? So we need to like swap it, I think. So we have roughly, as our like input, and we're inputting it here. Let's actually write out, or not write out, but let's move the letters to their like places here. Boom. Even though it's 5 points, like if you make a silly mistake, since it's so many like parts, you lose quite a bit of points. Why is it not able to move? Okay, oh. We'll just do that. For 2. Okay, that's good enough. And then 3 is B. And then 4 is A. Actually, we're not going through it backwards. That was my mistake. We are going the same direction, but we're like making different we're using the right side as input instead of the left side. So it should be not bad. Okay, 6. Let's do a time check, 4:55. Okay, let's go. R, oh my, R is L-O. Is O. F is PH. L is L. And then we'd have to loofily, like Would it be... The question is, would it split it up as UHL, or would it split it up as L, then EA? Like L and then E. I'm gonna do this one, Loufle. Because it would backtrack before going forward. Okay, let's pull up the answers and check it. Okay, let's find that. I think this is from 2022. It's called Stopping for a Spell. Oops, I opened up the problem instead of the solution. Solution. Oops. Well, see, okay, this is right, but the syntax is not right. Because it says that no output is produced, and then it puts the example here. So I'm going to mark this as wrong, but we did get this first part right. So keep that in mind. It was marginally correct, basically correct. Treaded, straighting, framing, striding, not straighting. I'm used to, because I have a different accent in this thing. Stage, yep. Staging, gaming, yep. Interesting. It goes C, D, C, D, B, A, E, F. C, D, B, A, E, F. How does that work? C, C, D. D is what? D is what I've put for 5. D is this one. It might work for this as well. He, right? H, E, he. And then it just moved to the end. People. It works for people because I built it off of kernel and people. Built, right? B, U, I, L, and then backtrack to T. Then forward, built. Interesting. Still not sure why that's wrong. And then that gave me loofle instead of loophole. Okay. L-O-O, right? Wait, but PH is literally F. Oh, okay. I think I messed myself up because I messed up the input and the output thing. So I got LE. It's just like F here, PH. Loop. And then since it's roughly, it would be L-O-O. Then L-E-A. I'm still getting a loophole. Loofle. But where are they getting the O from? Loophole. Maybe it does have to do with my order. Let's rearrange and see if that'll work. D was this one. So go C, D, oops, C, D, B is B, A is A for 4, E is 5 here. And then F is F. Okay. We start with R. R-U-H, Lou. F-P-H. O is nothing though, so like they might add an O. Loophole. Yeah, so there's nothing. Since O outputs nothing, it would be loophole if we were trying to create a like actual word. Trying to see what sequence of letters remains roughly. The thing is, it says what sequence of letters, so that's why I was a little confused. But now that we know that it should be a word. Loophole. Okay. So we started off good, and then it kind of devolved. But I still think that my order can still work, you know? Because it worked for all of those. It would have worked for roughly if I didn't mess up the order. I'll have to look more into this. Maybe ask on a forum or something. Anyway, the next problem I wanted to work on from there is 2022M. For me, I'm not sure. This might be the next one in the... I think this is from the Invitational, but it's still like intermediate. So I wanted to use that. This is about Thai. Writing system derived from the Old Khmer script. Unlike in English, in Thai writing there are no spaces between words. That's interesting. Thus, Thai word segmentation, the task of breaking a piece of Thai text into words, is a complex problem in computational linguistics. Pavan and Arun are both computer scientists who are trying to develop a word segmentation model for Thai. To evaluate the performance of their model, they use the F1 score, which is calculating using the following equation. This is the F1 score. I'm just writing it bigger so that I'll know where to find the formula later on. TP represents the number of true positives, FP represents the number of false positives, and FN represents the number of false negatives. A true positive is a case where the correct answer is a positive label, and the model returns a positive label. A false positive is a case where the correct answer is a negative label, but the model returns a positive label. And a false negative is a case where the correct answer is a positive label, but the model returns a negative label. In order to segment a piece of Thai text into words, Pavan and Arun's model take in the Thai text and assign a label to each character in the text. Specifically, the label should be 1 if the character is at the end of a word, or 0 otherwise. As an example, consider the following sentence. What is the time? This sentence has 4 words, counting the question mark as a word, which we can separate using vertical bars. We can further break the sentence into 13 characters. Some characters contain a dotted circle, indicating that the character combines with some other character that goes in the place of the dotted circle. Based on the word boundaries indicated before, a perfect word segmentation output would be 0, 0, 1, 0, 0, wait. Oh, okay. Because, hold on, how does that work? How would that work? Based on the word boundaries indicated before, perfect word segmentation output would be... So is that a single word? What is the 1s and 0s denoting? Okay, I'm gonna do this. We're gonna mark that. Initially, Pavan and Arun develop a simple baseline approach. Soon they learn a bit more about the Thai writing system. Based on this knowledge, they group Thai characters into several groups. They label some as vowels, some as consonants that can appear at the start of a syllable, and some as consonants that appear at the end of the syllable. Note that some characters appear in more than one category. Using these categories, Pavan and Arun each develop a new algorithm. All 3 of these algorithms are described below. Baseline algorithm. Label. Okay, so then this is like the rules. Right? These are the algorithms. Boom. On the next page 3, there are Thai sentences along with the F1 score that each algorithm achieves on each sentence. Unfortunately, Pavan and Arun have lost track of which algorithm is which. Match each algorithm name above, baseline algorithm, Pavan's algorithm, or Arun's algorithm to its label in the table on the next page. Algorithm A to algorithm C. Write 1 letter A to C per box. Okay. Let's check the baseline algorithm first. I'm going to copy this thing, and we're going to paste it over here. So the baseline algorithm says label the last character of the sentence with a 1. It's saying based on a perfect word segmentation output would be this. So I'm guessing we're checking it to this. I'm also moving up the character categories so we can view them. Let's do color coding. We'll make baseline green, right? Label the last character of the sentence with a 1, right? So all other characters with a 0. There appears to be, that's a vowel, right? So we're gonna have this initial consonant of initial consonant of this one plus 1 vowel to be 0, 0, 0. Word boundaries. Is a boundary included in there? Guess not. We'll just leave it as is. Maybe I'll actually insert the line in there. But then we won't be able to tell the difference between the one and that, so let's just keep it together. We'll include spaces. Okay, that's a consonant. And is that 2 vowels stacked on top of each other? No, it's 1 vowel. 0. 2. And then we have, I believe, 1, 2, 3. 1, 2. What's a character array? Hold on. Oh, okay, I think they gave us the character array so that it's easier for us to like write it out. But the question is, does a word boundaries have 1s in between? Like, are the word boundaries 1? Hey, but I mean, that's easier. So I just have to look here. Yep. 4, 5, 6, 7. This one has a tone indicator, has this one, and it has that. I'm assuming it'll go from top to bottom. So, I mean, I don't think it matters. So let's type it out. Baseline was 0, 0, 0, 1 0 0 1 0 0 1 0 0 0 1 0 0 1 0 0 1 2 3 4 5 6 7. Okay, that's baseline. Next one, we have, I don't think we can do this, color coding. There's not enough space for that. Okay, we have about 45 minutes left, but we've already solved one problem, so I'm doing better than last stream. Okay, let's get Pavan's algorithm. Try it out. This is actually super interesting, honestly. Like, I'm glad that we're getting more computational linguistics problems as opposed to straight linguistics problems like we were last time. Okay. Same, I will meet him tomorrow. So let's just highlight the final consonants in the character array. This Okay, so these algorithms are just for word segmentation. So the actual boundaries aren't needed, right? We can just put spaces in there, right? And where there's like false negatives or false positives, there's no false positives, there's only false negatives. There's like false negative throughout. All of these are false negatives, and then the one at the end is right, I guess, because the word is done. Is there only a question mark in Thai? I wonder if we get a calculator on NACLO. I should move the text up here. Okay. Let me just double check that, actually. Do you get a calculator on NACLO? You're not allowed to bring a calculator to NACLO. So, if you can't do something like this on scratch paper, make sure to practice. I'm gonna probably need to practice a little bit. Okay. So Pavan. Oh, we have to highlight consonants. I got distracted. Okay. Yep. Oops. Only the final consonant list. Final consonant. That's one. That's a vowel. Alright. Hey, but this is an initial consonant. It's not a final consonant. Okay. So that means that all other consonants are basically good. This is a consonant. It's not the last two that are excluded, so I'm just going to highlight it. This is a vowel. This is a vowel. This is a consonant not excluded by the initial consonants, because all final consonants are also initial consonants, except for two. So the only initial consonants that are not final consonants are two of them. So, and they're at the end of this like long line. So we just have to keep an eye out for these two and just make sure not to highlight them. Okay. This is a consonant, final consonant. This is a final consonant. This is a final consonant. This is a final consonant. This is one. And this is one. Okay, awesome. So, let's look at Pub 1, right? For all the characters that appear in the final consonant list, at the end of the problem, label them with O1. Right, okay. So it's going 0. No. It's top to bottom, right? So it'll be 0, 0, 1, space. Okay, this is actually, hold on, no. 1, 0, space. I was about to say it's going really well. 1, 1, space. This would be a hard, this is a hard issue to solve in the real world, though. I'm thinking about it, because the initial consonants and final consonants overlap so much that you're bound to get false positives and negatives and all of that jazz. So, you're gonna have to figure out a better algorithm than just marking the final consonants, because the final consonants, more than half of them, the majority of the initial consonants are also final consonants, which means that you'll be starting a word with an error as well. Okay, hold on, let's see. Overall, I definitely think algorithm A is baseline, because it does not seem like it would be good, but we'll test it for all. Okay. 0, 1, 0, because we have 1, 1, 0, 1, 0. That's in vowel, so it's 0. That's 1, space. 1, 0. 1, 1. 0. 1, 0. 1. 0, 0, 1. Alright, that's Pub 1. And then, let me just put a correct answer 1, 2. Correct would be 0, 0, 1. No, it would be something like 0, 0, 0, 1. you want to mark the characters at the end of the word as 1. So it would be 001 space 01 space 01 space 001 space 01 space 1 2 3 4 5 6 7 8 9 10 11. So that should be the correct answer, and then we can like calculate the differences based off that, right? So we have our run now. You know, it might be a much better idea to just do all of them together. So let's actually just do all of them together. Okay. Okay, test 1. Right, then we have test 2. Correct would be 001 001 0 0 0 0 0 0 1. I think that's 1, and then 1 2 3 1. Okay, and then let's do test number 3. Correct is 001 space 001 space 1 2. Wait, that's one vowel. Yeah, 1 2 3 4 5 6 7. That's 1. Okay. So these are the 2 correct ones. We'll do the baseline. The baseline should be the same, basically. It'll just be everything is 0. Except for the last one. 0 0. Oopsies. 0 0 0 0 0 0 1 2 3 4 5 6 7 8 0 0 1. And then let's move this. Let's move this somewhere like here. Oops. One, two, three, 4, 5, 6, 7. Awesome. Okay, we got baseline. Let's do pavan. Okay. Let's go. Okay. Pavan is... Okay, he's final consonant list characters, which is any consonant except for these 2. So let's highlight those in the array. We got, that's a vowel, that's a consonant, that's a vowel, that's a vowel, that's an initial consonant, that's a tone, that's a consonant that we're looking for. I should say this is a final consonant. We're looking for final consonants. That's a vowel. This is a final consonant. This is also a final consonant. Nice. That's a final consonant. That's a vowel. This is a final consonant. Nice. This is an initial consonant. This is a vowel. And then this is a final consonant as well. Wonderful. Okay, let's do pavans now. Okay, pavan for test 2 will be 0, 1, 0, space 0, 0, 0, space 1, 0, 1, 1, 1. Wait, no. It won't go 1, 1. It'll be 1, 0, 1. And then 1 again, space 0, 0, 1. Nice, the ending was right. Okay, so for pavan for test 3, let's highlight in the character array. This is not a final consonant, this is a not. It's just not. Highlighting this one. Highlighting this one, yep. Highlighting this one. That's a consonant. That's a final consonant. Highlighting this one. There. Highlighting this one. That looks like an N. It's very fancy N looking thing. Like, I would like that to be a font. It's very pretty. Okay. E, that's a vowel. Okay. Let's go. 0, 0, 1, space 1, 0, 1, space. There's probably a faster way to do this, but I should move my text. Hold on, give me a sec. I want to move the text on OBS so that you can see it a little better. But yeah. Okay. So 0, 0, 1, 1, 0, 1. This is 1. This is 1, 0, 1, 0, 0, 1, 0. Oh man, that was so close. Okay. Let's do Arun now, see if he does better. Hopefully. And then we can calculate all the scores. The best part about that, the fact that we can calculate the scores off to the side over here. We just need to copy paste the formula and then do all the calculations. Fun. Okay, let's grab Arun's algorithm, and oh, it's a long one. All right. Oops. Assign a label of 1 to all characters that satisfy the following criteria. The character is in the final consonant list. The character is preceded by a vowel. The character is followed by an initial consonant and then a vowel. Oh, okay. Interesting. Let me just write that out here. V, F, C, I'm just putting them in parentheses so that I know that they're separated. So we have V, FC, ICV, and we're looking at FC here. All right, let's go. So the character is not preceded by a vowel. Or is it? It is actually. Character is preceded by a vowel followed by an initial consonant and then a vowel, no. Right? So that won't work. Let's try this one. Preceded by a vowel. So, like, see, I have a question. Does it go like this? Like, do you read like this and then up and then you go down to this one? Or is it like you start at the top and then you make your way down? How is Thai read? Maybe I'll just Google that. On the exam, obviously you won't be able to. Left to right with vowels sitting on top and below consonants. So, it's just left to right, which means that the consonant has to come first here, right? So, technically, this one's not preceded by a vowel, so this is the only one preceded by a vowel, right? Initial consonant. Where is it? Yep. And then that initial consonant is followed by a vowel. Yep. So then this would be a 1. So it'd be 0, 0, 1. Next, I actually like this thinner pen a little bit because it's easier to write in these small spaces. Okay, this one not preceded by a vowel. This one not preceded by a vowel. So it'd just be 0, 0. Better than, I don't know if false negatives are weighed heavier than false positives, but yeah, okay. This one is a final consonant. It is preceded by a vowel, and it is followed by an initial consonant and then a vowel. Uh-oh. Kind of breaking down. Okay. Then we have, this is a vowel, that won't work. This one is a final consonant preceded by a vowel followed by a vowel. So it's not going to work. All three of those are zeros. Oops, what was that? Space. What am I doing? Okay, we have 0, 0, 1, 0, 0, 1, 0, 0, 0, 0. Now we have two of these. This is a vowel. This is a final consonant. So, preceded by a vowel, followed by an initial consonant, and then a vowel. Yep, so this one would work. So that's a 1. So it'd be 0, 1, which is correct. So this is taking a lot more time than I had budgeted. So we might just try and finish this problem on stream. And we definitely got to work on our speed over the weekend, on the weekend streams. And that'll be a goal. Then again, these are from the invitational round. I specifically chose like harder 15-point problems from the invitational round. I assume they'd be harder, but they might not be. I'm just assuming. But yeah, it's 5:41 right now. Let me think. Since it's 5:41 right now, I think we'll finish test 1 and calculate the, what was it called? The FTC, F1, the F1 scores of test 1. Yeah, we'll calculate the F1 scores of test 1, and then we will, based off that score, we'll probably get the algorithms. So we'll solve, we'll solve M1, hopefully, ideally, by the end of this stream. This one's a long one, though. It's definitely quite a bit more exhausting than the 10-point problems that I always do. Okay. Now this big last word, let's get into it. That's a final consonant following a final consonant. This is a final consonant followed by a vowel, initial consonant, then another consonant. Okay, few. So that's all zeros so far. This is a final consonant as well. What's a vowel? That's a tone, not a vowel. Okay. So this won't work. This one is a final consonant following a vowel. Following a vowel. Final consonant preceded by a vowel, followed by a vowel. Again, like this is not okay. So, and then this is the last character, so it has to be marked with 1. And these are, yeah. So it's just it's 0 0 0 0 0 0 0 0 0 0 1. 1 2 3 4 5 6 7 8 9 10 11. Which actually ends up working. Yeah, like that's actually the final consonant. So I feel like Arun would have the highest score here. Okay, but let's calculate it. Let me copy the formula for the F1 score. We're gonna slide this a little up so that we can see what the different scores are. But first we're gonna calculate the scores. So we know the correct one. Right, so we have F1 of baseline, oh my, okay, equals true positives, right? We have 1 true positive. 1 true positive over true positives 1 plus 1/2. False positives 0. False negatives 1, 2, 3, 4, 5, 5. So 5 there, so it becomes 1 over 1 plus 2.5. Oh my, okay. So that's 1 over 3.5 or 10 over 35. We'll just keep it as a fraction for now. Over 35 would be what? I kind of want to convert it to a decimal now and figure out what the baseline one is. Let's see. Let's actually do it. Okay. 10 divided by 35. This is really testing my math skills right now. 35, so 0 point, obviously. 2, 3 would be 95. No, it would not. It would be 105, so it would be 2. Here, 0, 1, 70. That's a 30. It's 300. Oh, there we go. 9. No, it's not 9. It'd be 8. But since it's 0.28, we probably 0.28 and then round, right? 35 minus 8, 0, 4. Did I do something wrong? I think it's fine though, because 0.29 and 0.42 are so far away from each other. This is definitely the baseline. Baseline is algorithm A is baseline. Ideally, I would check this with the other ones, but this is taking like a long time. Like, I am a little surprised by how long it's taking to just solve one problem. Just solve M1, you know? Then again, it's the invitational round, so I don't know if there's a different time limit or something, but yeah. So Pavan has 1, 2, 3, 4 true positives over 4 true positives plus 1/2 times how many false positives? 1, 2, 3, 4, 5, 6, 7, 8. 8 false positives plus 1, 2 false negatives. So that'd be 4 over 9, which is 0.42 about. So Pavan would be algorithm C. Which leaves Arun to B. And that would make sense because Arun is the most similar to the actual right answer. Alright, we've done M1. It is 5:49. Let me see how much more of this is there. Is it worth it to start M2? Oh, alright. Okay. Yeah, so I'm going to... I'm gonna do M2 because I think we can do that, hopefully. It seems to be more math heavy, so I think it'll be easier to like finish. Okay. So we're modifying the correct segmentation to be zero, 0, 1, 0, 0, 1. And then let's delete this last part and just say 0, 0, 0, 1, space 0, 0, 1. So that's the new correct one. We're gonna do Arun's algorithm. He's at the top. Okay, V, F, C, I, C, V. Okay. So Arun here. This is an initial consonant. No, okay. This is a final consonant. And it is preceded by a vowel, and it is followed by another initial consonant. So that means that this would be, this first part would be 0, 0, 1. Space. Next part, final consonant preceded by another final initial consonant. So it's not a vowel. I mean, it's not correct. The vowels, this is a vowel. So this is a vowel here. This is a final consonant preceded by a vowel, and an initial preceded by a vowel, followed by an initial consonant, yes. And then another vowel. Yep. Okay. So far it's like doing pretty well. 0, 0, 1. Then we have that's followed by a vowel, preceded by, no. This one is followed by vowel, vowel. This is a, there again, but it's like after that should be a vowel. And then this is the last character of the sentence, so it'd be 0, 0, 1, 2, 3, 4. Oh, but it's segmented differently. Right. So it would be actually here. We should do this one. All right, so we got these two segments are the same, right? This one preceded by consonant doesn't work. This one preceded, this is not a consonant. This is preceded by a vowel, and but followed by a vowel as well. So this would be 0 all throughout. 1, 2, 3, 4. Space. Oops. Yeah. For this one, that's a vowel, so it's a 0. This is a final consonant, but it's the initial consonant after it's not. It's actually not an initial consonant, so just be 0, 0, 1. Yeah, so the FC score for Urn here, F1A, F1, not FC, would be true positives 1, 2, 3. Oh man, that doesn't even look like a 3. 3 over 3 plus 1/2 times FP plus FN. So false positives here are none. 0 plus false negatives is 1. So it becomes 3 over 3.5. Which if we multiply top and bottom by 2, we get 6 over 7. Yeah, 6 over 7. 6 divided by 7. 0.8. 4E. 5. 35. 5, 0. Oops. 7. So it'd be 86.86. Or 6/7. All right. Let's check our answer for M2 and then yeah, I don't know if we'll be able to get another problem in, but yeah, this one's a longer section. This is definitely a longer one. Okay, let's grab the answer key. Okay. This is actually from 2022, I think. 2020. Is it a splitting disagreement? Yeah. Oh man, I clicked on the problem again. Okay, a splitting disagreement. Let's see. Oh, I was like, Arn's algorithm is A? No way. Baseline A, Pavan C, Arn B. Yeah, so you didn't really need to check. You only needed to check 2 against 1, because all of these have the numbers. And then 0.86, perfect. Okay, that's great. So we got those 2 right, and then we can resume the next one after that. I'm still slightly disappointed though that I didn't get L fully right. Like, I didn't get L as right as I've been getting M so far, you know? Like, time. Like, I still didn't understand why this was like that. Let me just see. Let's see if we can find a forum online or something that'll tell us about it. I mean, the last 4 minutes of the stream is gonna be figuring out this. Let's see. It's called, what's this problem called? Stopping for a spell. NACLO stopping for a spell. Answer explanation. I feel like Reddit might have someone asking that question. Reddit. There's bound to be an r//NACLO. Okay. If not, I'll just post on there asking. Because I am kind of confused. Okay, let's see. I'm gonna search for stopping. Stopping for a spell. Huh. No one's really asking about it. Honestly, not many people have been on the NACLO subreddit lately. There's only about 98 members. Yeah, last post is from about 2 months ago. Most recent one is from about 2 months ago. So I'll try and maybe I'll post on the Reddit, probably to promote my promote this channel, the stream, and then also to figure out this problem. Let me write that down. Stopping for a spell. Stopping for a spell. And if I'm not able to figure out that, I'll do stopping for a spell as a video. We'll like start over. Yep. Yeah, we'll do stopping for a spell as a video. Even though it's 5 points, this is like the problem that I was like actually struggling on, like pretty bad. But yeah, that is basically it for stream today. Since today is a Wednesday, we're gonna have 2 more days of morning streams, so 4:30 a.m. to 6:30 a.m. I'm not 6:30 to 6 a.m. PST. These are gonna be before school streams, so and I would have just woken up, so it might be a little bit chaotic, but it's fun. I really like waking up before school to stream and solve NACLO problems. Thank you for watching. The weekend streams, I'm still deciding if I want to extend them, because I definitely need more practice. So, and I also want to get some background music in the streams, but I'm kind of new to streaming in like OBS, because that's the software I'm using. So if you have any like tips for OBS or like putting background music in streams, I would really appreciate them in the comments. But yeah, that's pretty much it. yeah, I have a few more problems that I wanted to walk through today. I wanted to walk through 2021S. 2021S is piece only. Like this is another 15-point problem. Like I was looking through even the 2023 test, the most recent open round. That was a most of the problems were 15 points or 5 points or 10 points. There were no like 20 or 25-point problems like there were in 2008. So that was kind of my mistake there. But yeah, I think it's like changing with the times. Now computational linguistics is a little more popular, so they're probably making more computational linguistics problems, and I feel like they probably didn't want to put so much weight on one problem. At least that's how I would justify like breaking up the 25-point problem into like more 15-point problems, you know? Like, because if you absolutely mess up a 25-point problem, that's a much bigger impact on you than absolutely messing up a 15-point problem. So yeah, that is the stream today. I'll put a link to this one in the description and 2021S so that you can work on that as well if you would like on your own. And then I can walk through it tomorrow. But I think it would be cool if y'all did it first and then I could walk through it. But yeah, thank you for tuning in. Be sure to catch me tomorrow morning at 4:30 a.m. PST. Thanks for watching. Bye, everyone.